All right, let's jump right into this explainer. Today, we're diving into part 5 of a massive 12-part masterclass, and we're going to completely shatter the illusion of how we actually interact with our digital machines. If you care at all about the future of computing, AI, or honestly, your own creative agency, you are absolutely going to want to pay close attention to this. Just think about your phone or your laptop for a second. You tap, you swipe, you point, you click. We intuitively feel like this is totally natural, right? Because it's what we've been conditioned to do. But we really need to step back and ask a tough question. Are we interacting with computers completely wrong? We have to seriously consider if these heavy visual abstractions are actually holding us back from communicating with our machines at the literal speed of thought. So here's our roadmap for today. 1. The graphic interface dead end. 2. OS alpha versus the ALU. 3. Text, the semiotic bridge. 4. Software's operational literature. And 5. Wielding the divine script. Starting off with Section 1, the graphic interface dead end. To really kick off this paradigm shift, we've got to look at a stark dividing line. On one side, you have the graphical user interface, or GUI. It is highly lossy, and it requires massive computational power just to render things like rounded corners and drop shadows. Plus, when we try to automate it with AI, we're forced to rely on super fragile techniques like screen scraping, where the AI is basically just guessing what to click based on pixels. If a layout changes even slightly, the whole thing just breaks. But on the other side, we have the command line interface, the CLI. It's totally lossless, incredibly lightweight, and it generates a 100% exact high-fidelity text log of every single action. There's a quote from the source material that perfectly captures the tragedy of the GUIs. It says, "We get the chimpanzee hitting buttons, but we chat with each other. We could be hitting buttons, but it isn't as good." By forcing humans to click shiny buttons for a reward, we're actually dumbing down our deep, nuanced capacity for language. We're literally trading the profound complexity of human expression for a colorful lever. Which brings us to Section 2, OS alpha versus the ALU. To really see this grand computational illusion, we have to journey past the software, right down to the bare silicon. And to do that, well, we first have to look at ourselves. You and I operate on what researchers playfully call OS alpha. This is the human mind's primary internal operating system. It's a messy, fuzzy, highly associative, and continuous environment. It's entirely meaning-driven. This is the domain of pure human imagination, where all creative intent originates. But then we look at the actual machine hardware, specifically the arithmetic logic unit, or the ALU. Think of this as the ALU surveyor. And here's the reality check. The hardware doesn't understand meaning at all. It doesn't even know what a symbol is. It is totally unyielding, highly deterministic, and driven entirely by strict clocked voltage metronomes. A high voltage is a 1, a low voltage is a 0, but only if it happens exactly on the beat of that internal clock. It's utterly cold and completely mechanical. So the crucial point here is how these two systems handle complex math. In modern computing, we often rely on the floating point unit, or the FPU. The sources call this the FPU Gambler. Now, it's incredibly fast, but it's probabilistic. It uses secret, proprietary seed tables burned into the chip to essentially just guess the answer. Contrast that with the ALU Surveyor. It might be slightly slower initially, but it deals strictly in exact, absolute hardware truth. When we use the Gambler, it completely wipes out the original data's provenance in this messy wood chipper effect, permanently destroying the mathematical path back to the source. And this next number is just astounding, 80 to 90%. That represents the percentage of modern AI compute cycles that are actually just hardware-level approximations and highly educated guesses, rather than exact math. To put that into perspective, our massive AI systems are built on a foundation of hardware that is fundamentally just guessing. All right, Section 3. Text, the semiotic bridge. So how do we actually cross this massive, vast gap between a fuzzy, creative mind and a strict mechanical machine? Well, the answer is pure text. It's what the sources call the semiotic bridge. Based on the philosophy of Charles Sanders Peirce, text acts as the universal bijective interface. It is the ultimate lossless pipeline that perfectly maps our abstract human intent onto a physical silicon substrate. Pure text is literally the only way we can safely compile our associative imagination into exact hardware execution. Let's break this pipeline down step by step so you can see exactly how it works. Step 1. Human intent initiates in that messy, beautiful realm of OS alpha. Step 2. That flowing, continuous idea is forcefully squeezed into the rigid syntax of text. That's the semiotic bridge.
And finally, step 3, it becomes physical automated execution in the ALU. At every single step down this ladder, we are trading our fluid, expressive freedom for strict mathematical certainty.
I absolutely love this next description. The source material refers to this entire process as tricking rocks into thinking using lightning and text. It's kind of funny, but that poetic reality shows there is no ghost in the machine. There's no magic here. We are quite literally using structured text and electrical currents to command rocks to do our bidding. Moving on to Section 4, Software as Operational Literature. Based on this realization, it's time to completely reframe our understanding of code itself. Code isn't just a cold set of mechanical gears grinding away in the background. It demands exactness, yes, but it's actually a highly expressive continuation of human authorship. As the source states, we call programs tech all the time, but I believe we'll do a lot better at leveraging them if we recognize their literature. Think about it. When you write code, you're authoring a highly specific operational story. Let's see how this builds by comparing it to another form of highly exact writing, the law. Both the law and software are highly explicit functional literature with absolutely zero room for ambiguity. In law, a definition clause ensures total exactness of meaning. If it's murky, the whole contract falls apart. In software, variable scoping does the exact same thing. If a term isn't defined perfectly, the code simply won't run and throws a fatal error. A perfect historical example of this exactness is Donald Knuth's text engine. Created way back in the late 1970s, it relies on absolute mathematical determinism, using this brilliant system of simple boxes and glue to guarantee perfect, unchanging physical layouts across decades of different hardware. It's living proof that incredibly complex order and beauty naturally emerge when you apply simple, rigorous, deterministic textual rules. Finally, Section 5, Wielding the Divine Script. Let's unpack the profound philosophical weight of this reality in our modern AI era, because this matters immensely for how we build the future. We're facing a massive conflict right now. When we force the continuous associative thoughts of a probabilistic neural network through the ASCII tokenization bottleneck, using things like byte pair encoding, we get unpredictable hallucinations. The model's continuous ideas are just chopped into arbitrary chunks. And this is exactly why we must bind AI with compiled deterministic code. We simply cannot rely on the probabilistic guessing of the machine for high-stakes execution. We have to bound it with strict accountable text templates. To survive this wood chipper of probabilistic AI and actually maintain our accountability, the human author has to take on some very specific responsibilities. We have to act as the sovereign pilot, setting the high-level intent. We must author the constraints, using deterministic scripts. We have to maintain our legal liability, agentic tort. And crucially, we have to override the AI's automated miasma with manual authorship, what copyright law traditionally calls the sweat of the brow. Basically, you have to prune the output yourself. This quote right here anchors our entire masterclass today. As long as we have the author, we're good to go. Preserving the exact text, the pure intent, and the true identity of the author is the unshakable foundation for all future digital systems. The AI is simply a mechanism, a very powerful brush, but you are the painter standing squarely on the semiotic bridge. I want to leave you with this final provocative question regarding your role as the steward of the machine in this new agentic economy. As systems become more autonomous and much more probabilistic, will you actively wield the divine script, using pure deterministic text to build reliable infrastructure? Or will you just settle for a mere facsimile of intelligence and let probabilistic noise take control? The choice is entirely up to you. Thank you for exploring the architecture of the universal interface with us today. Remember to value your own creative agency, keep wondering, and always look past the screen. We'll see you in the next explainer